Welcome to Daily Physics Conversation. We have two students from two university. I have Ray from Ivy League Brown. I have Shubhana from New York University.
Hi.
Okay, so today our topic is interference. You can call it also wave interference. Wave interference when two wave. So let's say, can you describe this one? Yes.
So it's almost like adding two sine waves together. So
No, someone holding it up.
right. So
Can you tell me what happened? Two people holding the same rope.
two people are holding a rope. So one of them pulses it upward, and one of them pulses it downward.
Okay.
Then when the waves come to the center,
Okay.
they're going to subtract.
So Raf is moving it up and down, creating one pulse. Isaac is moving it up and down, create another pulse. When two pulse number one, or you can call wave number one and wave number two, going to meet at some point t, right?
Mhm.
All right. So what is the definition of interference? When two wave meet in the same medium, right? Then the resultant would be, this is the resultant.
It's like they are added together.
Okay, the resultant would be, if you call it A and B, the resultant would
It
be
gets
A,
bigger.
A plus B. In this case, of course. If it gets bigger, then you call it constructive. If it gets, if it cancels, then you call it destructive. For example, this one. Okay, so this is the really definition of interference. So let's dive in. Before I start, I want you to tell me, I wanted to graph really this one. Why? Let's say why. I wanted to tell me two things. Okay, hey, here. Scenario 1 and scenario 2. Scenario 1, how many poles?
One. You
Scenario,
have to specify. Are the two pulses traveling towards each other,
sure,
or just staying still, or
sure.
moving at the same
Sure, I'll tell you more information in a second. Scenario 2, how many poles?
Two.
One pulse. Sorry about that.
Really? Oh,
Okay.
okay.
So this is T1, this is T2, meaning that 0 second point T2, right? Okay, what does that mean? The pole doesn't stay at the same location, it moves. So this is, you can call picture version of a wave. This is called video version of the wave, or you can call it snapshot. If you go to ocean, you see ocean. If you take a picture and bring it home and claim that ocean exactly look like as same as the picture, would that be a true statement?
No.
What's wrong with that statement?
The waves move.
Yeah, it's changing.
It's changing. All right. The picture doesn't represent actual what's going on right now. However, it does give some idea. Okay, so this is a snapshot, this is a video, right? Which one give more information?
A video.
Video gives more information. If I have to write a wave over here equation, that would be y is equal to a sine bx plus c plus b. If I want to write the equations over here, yes.
You can't know B if you're in the picture, or C because it's not moving.
Okay.
So you can only know A and B, which stay constant.
Okay, that's right. Okay, so good. So just a sine x. If I want to write the equation for this one, then y x comma t is equal to a sine kx minus omega t.
Understand.
So this is a picture and this is a video. This gives you more information. This gives you a snapshot version. Okay, now let's ask you to draw the picture version of the wave and then the video version of the wave, or maybe the video version. Okay, maybe the video version of the wave. So y is equal to let's say 2 sine pi over 4 x minus pi over 4 t. First, can you tell me the wavelength? Oh, okay, so I'm going to draw it. So maybe I want to draw y with respect to x comma t. So let's say y and x, and let's say this is y and t. This is y and t. y and t. To do y and x, I want the wavelength. So Isaac, what is the wavelength?
The wavelength is, well, let's see. Sine. Okay, can I just
Yeah, you can try.
Okay.
And try to find the wavelength.
So let's see. So we have sine pi over 4x. Now I can basically ignore the phase shift and amplitude. They
Yeah.
have nothing to do with the wavelength. So let's just think about the function sine of pi over 4x for more simplicity. Now, uh, sine of 0 is always equal to sine.
Can I give you a little bit more hint?
No, I got it. Sine of 0 is equal to sine of 2 pi always. So now let's see, this is going to be the same when x equals 0 and x equals 8. Thus, the wavelength is just 8 minus 0, which is 8.
That's true. Okay, round of applause. Ref, can you find the wavelength another way? Yeah. So y x comma t is equal to a sine kx minus omega t. Can you use this one to find the wavelength?
Yes.
The way Isaac found the wavelength is excellent.
Okay. So the general formula is a sine kx minus omega t. K is the wave number and is defined as 2 pi over the wavelength. So that means the wavelength is 2 pi over k. Now here in this case, k is pi over 4. So that means the wavelength is 2 pi over 4, which is the same as 2 pi times 4 over pi. Pi cancels out. You get 8.
Okay.
Pretty good.
Let's try and get the right answer.
All right. So wavelength.
Please don't joke around right now.
So wavelength. So what are we gonna do with the wavelength? We need to draw. Okay. So how many points do you need to draw one cycle? 5. What is the last? What is the first point? What is the last point?
0 and 2 pi.
0 0
And 8. Sorry.
0 0
0 0 and 8 0.
0 0 and 8 0. Okay. So this is 8. All right. So this must be 4. This must be 2. This must be 6. This must be 2. This must be -2. First point is this. Second point is 2 comma. Third point is 4 comma 6 comma 8 comma. All right. Okay. Good. Now I'm gonna do this one, and I'm gonna slide it over here, right? Exactly over here. So all right. Good.
Yep.
16 meter. So Isaac, my question is, what is the wavelength?
Of what?
What is the wavelength of this wave?
It's 8.
I wrote 16 over here. Why did you say 8?
Because it's 2 cycles.
Very good. So, okay. No, I wanted to confuse him. Okay. So, what should be the definition? Some student really, when I put today 16, as soon as I put 16 meters, they say wavelength is 16. That's really happened. And then I put one more cycle, right? 24, and they said wavelength is 24.
Wait until they find out sine waves are infinite.
Yeah, and I said, well, it can go forever. Wavelength will then infinitely long. Okay. So what should be the wavelength definition? Distance over
Cycle.
cycle.
Number of cycles.
So distance over cycle. So it doesn't really matter how long it is, because distance is 16. So this is not wavelength. This is distance, and cycle is 2. So yeah, you're gonna end it up 2 anyway. Okay. So now, if crest to crest is lambda, what is trap to trap? And my
Also
student, okay, my student said if this is lambda, this is something else. So if this is lambda, this is also lambda. What about from here to here? That's also lambda. Okay, so now we are done with this guy. Now let's find the period.
Yeah, we should talk about in phase and out of phase.
Yeah, we're gonna do that. Isaac, can you find the period?
Right.
Now you're gonna do y versus t graph, and we need the period.
Oh, y versus t. Okay. So just finding the period outright, I'm pretty sure. Correct me if I'm wrong. It's 4 over pi, but I think.
No, period is not 4 over pi. You can try by using the skeleton.
Right here, omega is known as the angular frequency. So if you learned about springs and simple harmonic motion,
It is harmonic motion.
yeah. So if you learned about harmonic motion before, essentially you will remember that it's just 2 pi divided by the period. So now, in this formula, omega is clearly pi over 4. So let's just plug that in and solve for t. So then you can see these two cancel. Then we're going to divide by 2 to get rid of this 2 in the numerator. So that becomes 1 over 8 equals 1 over t. So it should be pretty clear that t is 8 seconds.
So now, Brown, can you do the graph?
Yes.
Since we have the period. Again, use the 5 point.
Okay, so the period is 8 seconds. That means that our last point will be 8. That means our midpoint will again be 4. That means this is 2. That means this is 6. Okay, and
These are not in terms of meter. These are in terms of seconds.
seconds. That's right. That's an important point. The units, even though the numbers are the same, the units are completely different. This
Yeah,
is a
the
less
wave
scale,
is going
this
to
is a-
look the same, but they don't represent the same things in reality. We just chose a wave where these are the same because
This is-
coincidentally,
this is-
please, k is equal to double omega, so they both are the same. But in any other case where k is not equal to omega, these two are going to look very different. So please don't be confused.
That's right. This is a snapshot of the wave at a single moment in time, and this is the wave evolving. In time.
Specifically, that's a snapshot of the
Okay,
wave at t
Great.
equals 0.
So let's see. Let me just erase this one so I can draw the wave. So this is I
Put
guess,
2 and negative 2 again.
okay, this is 2. This is minus 2. Okay. Okay, at 0 we are starting from 0. At 2, 2, 4, 0, 6, minus 2, 8, 0. So,
Yeah.
okay, good.
Alright. So this is one cycle.
Wait, no. I have a question to ask every student, okay?
Yes.
Okay, Brown, come back.
So, oh, wait, why did I say thank you? It's obviously for refab. Great job. Okay, so now I have a question for every single student. Okay, so now we have a crest here, and this is 10. What's the period? And now I have a different question for you. I'm going to extend it to one full cycle.
That's too much for them. That's too much.
Just at 16 period because.
Alright, what is the period of this?
It's still 8, but
Yeah.
but you are.
I understand why they get confused.
Yeah,
Because it looks like 2 waves.
that's right.
I
Or
think-
it looks
Or,
like.
no, they would think.
Yeah, they are not thinking about wavelength. They are thinking about wavelength. Two very different things.
No, they're thinking.
Okay, sure. Wavelength could be distance,
Yeah,
and wavelength is cycle.
yeah.
No, they might be thinking that okay, if it stays the same, then why did he draw something new?
Yeah, that's
Yeah.
true.
I
That's
know
true.
that's what I was.
Okay,
Because you're
if
stupid.
okay, if this one is the case, then
Uh,
how can oh, by the way, congratulations for winning the Michukaku Award.
Congratulations.
All right, what makes you different than us? We are not Michukaku scholar, but you are.
Do I care?
Okay. Here, can you write the period is time over cycle? Can you do that?
Okay.
Here, right here.
Oh,
Period
there's
is
not
time
much
over-
space, but
Period is time over cycle.
equals time. I'm trying to write it big so people can read and understand and all that good stuff.
So time is 10.
Yeah.
And write cycle.
Now cycles is just 1 and 1/4.
No, that's 1.25.
Same thing, just written in mixed notation.
So it's still 8.
Yes,
Okay.
Don't-
No, it's still 8.
Don't get your marbles juggled, Rita.
Okay, so it's still 8. So
Don't lose your
everybody
marbles.
Everybody knows what to do. Okay, now let's go back to it.
Please stop sitting in my seat.
Don't forget today's topic is interference, not trigonometry.
And please don't forget today's sponsors.
Today's it's look like today we are learning trigonometry. Somehow math finds its way
Somehow?
to
You should know, Dad.
to um, to take the beauty away from physics.
What?
But you do.
Yeah. Yeah, somehow math finds a way to take the beauty out of physics, but what can you do? So now guys, I'm gonna give
The
you
whiteboard is here, no?
yeah, you are trying to
Sorry, I'm getting this back.
okay, so you have one example, right? This is y1, this is y2. Okay, this is problem one. You're gonna solve problem one. Raf is gonna solve. They go both gonna meet at t. So you're gonna write at t. You're gonna write equation one y1 plus y2 is equal to what? Y1, by the way, y1 is 2 sine let's say kx minus omega t, and y2 is 2 sine kx plus omega t.
But then they wouldn't be heading in the opposite. Oh, yeah, they would. I see. We've had set up.
And y1 plus y2, you're going to write that over here. What the k you want, okay, and what the omega you want. So you specify that.
Oh, you
Number
decide
2.
pretty fast.
Isaac gonna do this one. This is A, this is 2, this is B. A and B are same magnitude but opposite in.
Correct.
They meet at t. So Isaac gonna write the equations y1 plus y2 plus y2 over here. Isaac also gonna write the equation for here, equation for here. Okay, let's see the diagram. Brown, you know exactly what to do. Okay.
I can choose my own k and omega.
Yeah, but first add them up.
Okay, so sure. Alright folks, so the first step to add them up is just write them. Because they don't have the same sign, we can't add 2 plus 2. So we have to write them separately. So 2 sine kx minus omega t plus 2 sine kx.
Hey, isn't
plus
there like
omega
a
t.
sine addition formula that you can use for this?
You can do that for you.
Please don't be mean right now. Being destructive, when I'm trying to give you constructive criticism, it's really not working
Okay.
out.
Now
All right, you can choose your k and omega.
so let me choose my k and omega to be something simple.
Whatever he chooses, you have to choose that. So
Understood.
So let me just remind the viewer that k is defined as 2 pi over lambda, and omega is defined as 2 pi over the period. Okay.
can you erase one?
Yeah. Okay. You could also write it as 2 pi times the frequency. So let's see a good value of lambda. We can choose
Pi.
lambda to be pi.
It's up to you.
Actually, okay, let's say lambda is 2, then k is just pi. So lambda is 2 meters. If the wavelength is 2 meters, then our wave number is just pi.
Okay.
And we can choose our period to be, let's make it a little interesting, 4 seconds. So then our angular frequency is
Okay. You're gonna do it that way.
actually this is 2 pi. 2 pi. So 2 pi seconds. So 2 pi over 2 pi.
What did you choose your frequency? 1?
Yeah, actually,
Your frequency is 1?
the period to be 2 pi. So 2 pi over 2 pi just gives me 1.
What is your frequency? Frequency is 1? Oh no, what is your frequency?
Angular frequency?
Yeah.
This one.
Okay.
Or is that too simple?
No, it's fine.
Okay. So great. So so now I'm gonna plug that into these equations. So y1 equals 2 sine k is pi.
Can you choose 6?
Pi. This one.
your frequency
Yeah,
6.
yeah. Okay, yeah. Let's get something else. Let's say 4 pi. Then my frequency will be. Oh, you wanna make the
6 6.
frequency 6? Then pi over 3 6
No, 12.
gives me 6.
No, it's gonna give you 12. Frequency 6 is 12.
Genius.
No,
2 pi times 6.
Yeah.
2 pi
2
times
pi.
6.
Yeah. This
12 pi.
this gives me 6 because if I plug in
If
2
you
pi.
if you plug in 6, replace f by 6.
Oh, you want 12 pi?
Yeah.
Oh, I see what you mean. Okay.
What a dummy.
Okay, so then the period is 1 over 6, right? Or frequency is 6, right?
Yeah.
Okay. So then omega is 2 pi times 6, which is 12 pi.
Okay.
Okay, great. So k
Pi
is
12 pi. Okay.
pi x minus 12 pi t, right?
Yeah.
Okay, good?
Yeah.
Good.
Isaac, you're gonna choose the same thing.
So
Okay.
now this is gonna have the exact same equation, but this is gonna be a plus sign, 2 sine pi x plus 12 pi.
No, why did you go there?
Oh,
It's not done yet.
Yeah. Now, depending on when we want them to meet, we have to choose a certain phase shift. So
Okay.
let's see.
Let's just say
One-
they meet right in the middle and let the phase shift equal 0,
No,
okay?
No, it's not about where they meet. It's about when they meet.
Where in both of them
When-
are affected by the other.
When do you want them to meet? 1 second, 2 seconds? Up to
Give
you.
it time.
Well, it depends.
You say you can you put a like a barrier over here? So Isaac move
It
it up and
depends on
down.
the distance between them.
Isaac move it up and down, and Rap move it up and down.
Okay, can I
So they meet at part T, and T
No,
can be.
can I say something for 1 second?
Yeah.
It also depends on the distance between them, not just like anything.
You'll see that it
Jeez,
gets figured out in the math.
Okay.
Okay.
It's hard for you to understand.
Pick a number for this.
No, Rap pick a number. Time.
Okay, let's
Pick a number.
Yeah, go back to
Jeez.
your seat.
Oh my god.
Isaac, you do this one. Let him finish this one, and then if he made mistake, then point it out.
He
How
made
about that?
several mistakes.
Okay.
Okay, so I'll pick a time. Let's say they meet at 3 seconds.
Okay.
Okay.
So after 3 seconds, they will hit each other. So okay. So let's see. At t equals.
They will at the superposition with
Right.
each other.
They
So-
will be in the same location, right?
So then, what
So
are you
now-
finding?
Now I'm trying to determine what phase shift will force them to meet at 3 seconds.
You can't do
So
that without the distance between them.
Y1
Jeez.
is, let's plug in 3 seconds. So 2 sine pi x. Oh, I think I should do it here. It's getting a little crowded.
Yeah.
Let me do it here. So y1 is 2 sine pi x minus 12 pi t. But now I want them to meet at 3 seconds, right?
Yep.
So let's see. Where is this wave at 3 seconds? Let's see.
There's a phase shift of exactly 36 pi.
So y1 is 2 sine pi x minus 12 pi times 3. So
That
12
just equal
pi
to 2
times
sine
3
pi x.
is 36 pi. So 2 sine pi x minus 36 pi.
Does he know what he's doing?
Yeah.
Okay.
I-
You can simplify that to 2 sine pi x.
so far so good.
Just simplify it.
Or-
Simplify it.
Relax, relax.
Oh my
Okay.
God.
It's okay. Yeah.
It's-
Let him do his own way. This is the brown way.
I'm done with you, Rifat.
Now,
You will face justice.
yeah, I feel justice by getting accepted to my belief. So let's see.
You're gonna get kicked out on your first year.
Yeah. After I win the National Medal of Science. So Y2.
Do you hear this guy?
He gonna be the youngest.
Youngest blah 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 blah.
Hold on.
Maybe I'm like blah blah.
Okay. So let's do the other one. So the only difference here is there's a plus instead of a minus because it's heading in the opposite direction.
Cool.
And I want to pick a number here, a phase shift here, so that they're in the same location at 3 seconds. So at 3 seconds, what is this? So pi x plus 12 pi. But instead of writing t, I'm gonna.
You're gonna write
seconds.
minus 72 pi for phi.
So now this is 2 sine pi x. 12 pi times 3 is 36 pi plus my phase shift. But remember, I want them to be in the same place. So let's compare these two. See, everything is the same. 2 sine, 2 sine. But look inside. Pi x minus 36, pi x plus 36. How can I make this plus 36 into a minus 36? By choosing this phase shift to be minus 72 pi. So then this whole thing becomes pi x minus 36 pi. Okay, so now we figured out what our phase shift should be. Now I can come back here and I can replace this with our phase shift minus 72 pi, and now that forces the waves to interfere constructively at 3 seconds. At 3 seconds. So after 3 seconds,
They would be superposition with each
they
other.
will be at a superposition. So let's show what the superposition is. Can I erase this, or the
Yeah.
Erase it.
viewer needs them? Okay, so okay, so let me erase this. So that was just to get the phase shift. So let me now show what the superposition is at 3 seconds. So y1 is 2 sine pi x minus 12 pi t. Right? So far so good.
Yeah.
Okay. Hopefully you follow.
Refat, please
Okay.
shut up.
Y2 is 2 sine pi x plus, because it's heading in the other direction, t, minus 72 pi, so I can force them to meet at the same place at 3 seconds. Now let's see what it is at 3 seconds. At t equals 3 seconds, what is y1? Y1 is 2 sine pi x minus 12 pi times 3, 36 pi.
No comment.
Y2 is 2 sine pi x plus 36 pi minus 72 pi plus 36 pi minus 72 pi. But what is 36 minus 72?
It's minus 36. Refat, please stop. Everybody already knows those two are the same.
Now look, y1 and y2, they have the same formula.
Sure, we have
So
eyes.
we can just add them up. Y1 plus y2 is then 2 plus 2.
You're very funny.
No, I know you can answer that one.
I'm going to throw a marker at you if you ask me one of those stupid questions again.
Okay, so instead of this one now, can you replace this one by that?
BS.
Yeah.
4 sine pi x minus 36 pi. Now the most difficult part is to draw the diagram.
Yeah. So it used to be at 2, but now after they constructively interfere,
And remember, don't make it.
the new wave will be at 4.
Don't make it. Oh no. Okay, good.
Isaac, you
no,
do this one.
I would advise not drawing it like this and redrawing it like this.
Thank you for
Yeah.
your
Do you know why?
No, I don't.
Because high school students tend to really love this kind of shape.
Oh, you are not high school student. Oh yeah, you used to be. Okay, good.
Yeah, this is a
Okay.
very bad shape.
Okay,
All right.
All right, Isaac, you can erase as much as you want, but let's give a round of applause to Brown. Okay.
Yeah, I'm just clapping because that was actually impressive. It was impressive the amount of BS that he can manage to fit in one rigid physics problem.
Remember,
Like, it's not even that advanced, and he still managed to get every step wrong.
Remember, my equation has a negative sign, and I still don't know why.
It fits with the experiments. That's why, you fraud.
Isaac would be like, he would be like with the prime minister and giving his speech, right? And I would be standing next to him, and every word he say, he look at me for approval or maybe see my expression. I mean, you don't. You are standing with.
No, because sometimes I look and you're like, and then I turn around 10 seconds later and you're like,
No, then what
I'm
I
thinking,
the
what
last
the fuck
time.
I said wrong.
No, last time what I did, I closed my eyes because I wasn't allowed to leave it, move from that location. So I closed my eyes. So he knows that I really not pay attention what he's talking about.
Yeah.
I close my eye. Hopefully he understands that I'm not paying attention to what he's saying.
Has an amplitude of -3. Is that okay?
Wait, that's
Oh,
not
sure,
possible.
sure. Yeah, he doesn't
The
want.
magnitude is 3.
He doesn't
genius.
want. He doesn't want the sum is 0. He wants sum is -1. Yeah.
Oh, that's interesting. The ape says if he scratches his fur. Oh, that's interesting. As he grooms himself. Okay, so I just can't hold it back anymore. 2 sine blah, 2 sine pi x minus 12 pi t because we have to pick.
Remember, you are not teaching MIT student. You are teaching like the guys who have no background or never seen trigonometry in their life.
Come on, don't be mean.
Okay.
Imagine if they saw this. They'd be like, Mr. Barry.
Now, some country people learn it in kindergarten, to be honest.
Do you believe him?
It's true.
Yeah, that's what I
It's true
thought.
statement. It's not like opinion to debate. It's like a fact to deal with.
Blah, 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 blah.
Okay.
Okay, so I hope this is correct.
Which is?
Why do you look like a chipmunk? Like a Neanderthal almost. So we have -3 sine pi x plus 12 pi t plus 5. So now we're going to figure out what this final resultant is. So now any old person could say, well, this is. Man, you treat that like the US flag. Better than the US flag, in fact. And that's not good.
Nothing is more sacred than you respect.
Not to revac.
No, he.
Yeah, right. Okay. I'm sorry for messing that up a little bit. Messy handwriting, but that's okay. I think we can deal with that. Now pick a time, and he is not
Oh
allowed
no,
to
it's
vote.
the same thing. 3 seconds.
Oh shucks! You really have to be on original. Okay, so the time for them to meet is 3 seconds. So it's basically the same exact thing. We want to figure out when these two are in phase, i.e. sine pi x minus 12 pi t is equal to sine pi x plus 12 pi t plus 5. It's essentially the same problem.
Simple concept, but it's really lots of trigonometry.
So at t equals 3. So once we do that, we just get the same exact thing. Equal sign of. Now, obviously, for these two to be the same, it's -72 pi. Now, let me address something. Now, depending on what x is, these two might actually not cancel out completely. But just assuming normal conditions, both of them, one of them is at a crest and one of them is at a crown, then shut your gullet. It's just going to look something like this, minus sine of.
But show that the superposition is minus.
Yeah, it's literally right here.
No, add them together and show that it's minus.
Yeah, -1.
Okay,
Just
yeah.
like I did.
Okay, so how did you add them together? You
No,
should know
you.
indication. You just
No, he erased
I
them.
did the
Okay.
math. You have to add y1 plus y2.
And you have to plug in 3. You have to plug in 3.
Equals -1. Yeah, I plugged in 3,
No.
right?
No,
Okay,
do it
Dad.
nicely. Do it nicely.
Wait, 1 second. 1 second. All right, just chill. So once you add these two together, you get 2 sine pi x minus 36 pi minus 3 sine pi x minus 36 pi. So this has to be minus 1 sine pi x minus 36 pi. Is that not adequate?
I think that's okay.
I think that's
So anyway, you have a way.
And that is, can you write y1 plus y2 is equal to that?
Yeah, okay. So you have a wave of amplitude 2, then you have one of amplitude 3 in the negative direction. And so once you add them together, or as if you're like averaging them out or subtracting vectors or something like that,
You get this.
yeah, you get this line right over here.
Yeah, it's like 3 minus 2 is 1. Or,
Yeah.
okay.
So minus sine pi x minus 36 pi. There it is.
All right, I did not know. I thought that today's lesson is like 2 minutes, but it's interesting. But the lesson should never be more than 40 minutes, no matter how what the topic is. So I'm gonna just move to the exercise. Is that okay?
Yeah, please.
I gonna give you 3 equations, and then the first one I draw, second one Rep draw, and third one you draw. The first equation is y is equal to, please pay attention, 2 sine pi over 4 x minus pi over 4 t. So this one I'm going to draw it. I'm going to draw it over here. Maybe I'm going to make it long because I need that. Okay, so the first one is this 2, negative 2, 1 point, 2 point, 3 point, 4 point, 5 point.
Don't you have to draw both an x and a t graph?
I'm just not gonna mention the x, y, and x. Just to save the time. You want me to do both?
No, but you have to specify which one is this x or t.
All right, let's do t. Okay, so is that okay?
Yeah, that's fine.
All right. So no. Okay, maybe we can do two cycle.
What's the wavelength?
All right, wavelength is still 8. Okay, so this is black. So I'm gonna do the black one. Y is equal to what? 2 sine pi over 4 x minus pi over 4 t, right? And Isaac gonna do the blue one on top of this one. So this is, I'm gonna call y1. So this is y1.
Oh, that can you put 8?
Oh yeah. Okay, y2, Isaac gonna do y2. 4 sine pi over 4 x minus pi over 4 t.
Wait, okay. Well, this is the same exact graph, but the amplitude is multiplied by 2. So you just have 4 and minus 4, and
Careful, slow down.
they're not even a. Why slow down? It's
Don't make mistakes.
literally exactly the same.
Oh, write y2, baby. Okay, Raf, can you take the sum
Oh,
y1 plus y2 on this graph? That's the last thing we do. If it is there any red? I don't know.
yeah,
Okay, I have purple.
we should have
wow.
plenty more markers.
Okay.
Yeah.
We used to have a lot more.
Okay.
Okay, so y1 plus y2 is 2 plus 4 is 6. And they're in phase, so I can just add them up like this.
Oh, this works.
Pi over 4.
He will take it.
Pi over 4x.
Oh, purple is as good, baby.
Pi over
Let's not waste too much time.
So 2 plus 4 is 6. And minus 6.
Jamie has figured it out at this end.
And let me make sure that
2 plus 4 is 6. Huh.
no, for some people that's
Like you, who are mentally challenged. Like, seriously, how do you get a 43 on the MC?
by working hard.
So yeah, please write, baby, write y1 plus y2.
By working hard to get every question
All right.
right.
Okay. Thank you so much. Let's give a big round of applause for Brown.
Why are you giving a round of applause for yourself?
Okay. Now look. What do you call this one? Destructive or constructive?
Constructive.
Good. Okay.
If they were out of phase, they'd be destructive.
Yeah. This is in phase. What is how much out of phase this one?
Zero.
One thing you learned today, and one thing was challenging.
So one thing that I learned today was how to sum up two waves that are facing in the opposite directions in destructive interference. That was a very challenging problem, just giving the functions of two pulses, trying to find the function of the wave that's created when they interact. So that was a nice problem, and it really challenged me.
I learned how to graph a sinusoidal, and I learned how to calculate the wavelength and the frequency from k and omega.
Every lesson is supposed to give you an opportunity to discover at least one thing. What did you discover?
So I discovered how to find how to find the overall equation of a constructive or destructive interference, and that was really interesting.
I learned how to calculate the phase shift so that two waves interfere at the same time.
Every lesson plan is supposed to give you a challenge which may or may not be overcome within the time period of 40 minutes. What was the challenge that you're probably going to be thinking next 24 hours or so?
Understand the grief at explanation. But anyway, just to be sure, that a problem was definitely very hard, and that was a challenge that I'll definitely be thinking about and improving on. And one thing I wanted to explore, but I didn't get the opportunity to today, was what if the frequencies of the two waves or their velocities are different?
And one thing that I'd like to explore, or I was challenged by, is I had the misconception that adding more cycles changes the wavelength or frequency, but I guess that doesn't.